Hi. So in the previous lectures, we have seen informal guidelines. Then we have defined what is a functional dependency. Then we have seen what do you mean by this normalization. So normalization is a process of decomposing relations, bad relations, such that it becomes good relations. Then we have seen what do you mean by this normal form. Normal form is a condition. Then we have already also defined this keys, super keys, candidate keys, primary key, secondary key, and also we have defined prime attribute and non-prime attribute. In this lecture, we will be seeing first normal form, second normal form, and third normal form. So first normal form. So first normal form is considered to be part of the definition of a relation itself. So we'll see why it is considered as a part of the relation itself. So first normal form says that all the relations should disallow composite attributes. So there should not be any composite attributes in a table. We have already seen what is a composite attribute. Name is an example for composite attributes because it consists of three components: first name, middle name, and last name. So such kind of composite attributes should be disallowed, or it should be avoided in tables. Then it should not have multi-valued attributes. We will see example for multi-valued attributes. Department location is an example for multi-valued attributes because a department may be located in several places, so it will contain several values. And third one, it should not have nested relations. Nested relations means a relation within another relation or a table within another table. We will see the example for multi-valued attributes and nested relations, and also we will see how to make it into a first normal form relation. So the tables should have only attributes whose values for an individual tuple are non-atomic. That means it should be simple and indivisible attributes. Then we can say the relation is in first normal form. So most of the RDBMS allow only those relations to be defined that are in first normal form. So when you try to create a create a table which is not in first normal form, then automatically this RDBMS will not allow you to create such tables. So it has become part of the definition itself. But we have to study the theory part of this first normal form because this first normal form, second normal form, and third normal form was written in 1972. Then the DBMS did not include this first normal form as part of the DBMS package. So we will see example for this multi-valued attributes and nested relations. So this table, department table, the primary key is D number. We have attributes D name, D manager, SSN, and we have a multi-valued attribute D location because a department may be located in several places. So if we take the instance of this table, it will be like this. Research department is located in 3 different places. We can rewrite this table like this. So if we check this table, there will be 3 rows for research which says that research manager SSN value is this one. So it is a redundancy problem. There will be a redundancy problem in this table. So we should not have multi-valued attributes in this table. So one way to remove this multi-valued attributes is to, if we know the department location will be located at a maximum of 3 places, then we can include as 3 different attributes: D location 1, D location 2, and D location 3. But the problem with that definition is the table may contain null values. So in informal definition, we have already mentioned that tuples should have minimum null values. So if we define 3 different attributes, or if we can say that the department will be located at a maximum of 5 different places, then we can have D location 1, D location 2, D location 3, D location 5, 4, and D location 5. So we can include as 5 separate columns. But the problem with that definition is the table will consist of null values. So that is one way to solve this take this table in their first normal form. And another way is there. So what we do is, here the department location is a multi-valued attribute. So we separate that attribute. we remove that attribute from this table and we create a new table which consists of this multi-valued attribute and the primary key of this attribute. So this table can be normalized like this. So department table will consist of D name, D number and D manager SSN. And we have removed the department location into a separate table and we have included the primary key of this table in this table, D number, and we have created a new table, department locations, and the primary key of this table will be department number, comma, D location. So the combination of D number, comma, D location will be the primary key of this new table. So we have normalized. This table is not in first normal form because it contains a multi-valued attribute. So in order to make it into first normal form, what we have to do is we have to separate this multi-valued attribute into a new table. So that's what we have done here. So now this table is in first normal form because it does not have a multi-valued attribute and it does not have a nested relation. So next we will see what is a nested relation. So this is an example for nested relation. M project. It consists of attributes SSN, E name, and P number and P hours. So this is a relation. It consists of a nested relation. Projects P number and hours does not belong to this employee table. It has no relation with this thing. So if you insert some values into this table, it will be like this. So you can see Smith works in two different projects. So two rows will be there for this Smith. And similarly, if Wong Franklin, he works on four different projects. So there will be four rows saying that SSN value for this employee is this one. So there will be redundancy. This is because this redundancy happens because there is a nested relation. There is a relation within another relation. So in order to normalize this relation, what we have to do is we have to decompose again. We have to decompose into two different tables. The first table will consist of SSN, E name. So here we can see a table M project 1. So this table has been decomposed into M project 1 which consists of SSN and E name, and the second table M project 2 which will consist of the primary key of this table. Additionally, it will consist the attributes of this table. So it will be SSN, P number and hours. And we should include this P number and SSN as a primary key because P number is the partial key of this table, projects table. So the primary key of the new table will be SSN, comma, P number. So in this way, we can make it a first normal form. So these two tables are in first normal form. So if you check, there are no nested relation, there is no multi-valued attribute in this table, and also there is no multi-valued attribute in this table, and also there is no nested relation in this table. So these two tables are in first normal form. So what we did is we have decomposed this relation into two different relations. In the first relation, we included SSN and E name, and in the second relation, we have included P number and hours, and also we have included the primary key of the first table, SSN, and in the new table, the primary key will be primary key of this original table plus the partial key of this table. So this combination will be the primary key of this table. In this way, we can normalize. So we will see another example. This is another example for a nested relation. We have two different nestings. So candidate relation, here SSN, name. Then there is a nested relation, job history, company, highest position. And inside the job history, there is another nested relation, salary history, which consists of year, comma, maximum salary. So the primary key is SSN for the whole table. Then company is a company. So SSN is the primary key of this table. The company is the partial key of this job history table, and here is the partial key of the salary history table. So what we should do is, so we should make it into three different relations, or we should decompose it into three different relations. So first table will consist of SSN, comma, E name. So we call it as candidate 1. Then second table will consist of these two attributes, highest company and salary position, and also we have to include the primary key of the parent table. So SSN comma SSN comma, let me take this. Okay. So SSN comma company will be the primary key of the second table, and highest position will be the another attribute. Now the third table will consist of SSN, then company, primary key of this table, and also year, the partial key of this table, then maximum salary. The combination of SSN comma company comma year will form the primary key of this third table. Now these three relations are in first normal form because it does not consist any multivalued attributes and it does not have any nested relations. So in this way we can normalize into first normal form. Another example for multivalued attribute. For example, we have a person table which consists of social security number and car license number and phone number. So here car license number and phone numbers are multivalued attributes. Social security number is a simple attribute because a person can have only a single social security number, but a person can have multiple cars. So there will be a different license number for that person. A person can have 2 or 3 phone numbers. So in order to normalize this thing, what you have to do is, according to the previous definition, what you have to do is we have to include all the attributes, all the multivalued attributes into a separate table, and combination will form the primary key. So in this way we have to normalize. But still this table will suffer from the redundancy problem. So this is not the right way to normalize. What we have to do is we have to take each multivalued attribute and make it into a separate table. So it should be like this. So SSN comma car license number will be P1 table, and P2 table will consist of social security number comma phone number. So we have to separate the multivalued attributes into two different tables. So person table will become P1 and P2. Now these tables are in first normal form because there are no multivalued attributes. Then next is second normal form. So this second normal form uses the concepts of functional dependencies and primary key. We will define something. So we will define a prime attribute. So in the previous lecture, we have defined prime attribute as an attribute that is member of any of the candidate keys. Now we have changed the definition as a little bit. Here, a prime attribute means it is a member of any, if it's a member of the primary key. If it is a member of the primary key, then it is known as prime attribute. Then we will define what is full functional dependency. So if there is a functional dependency y to z, then we can say z is fully functional dependent on y if removal of any attribute from y means the functional dependency does not hold anymore. Then we can say it is full functional dependency. So we will see with an example. So if we take this table, we have SSN, P number, hours, E name, P name, and P location. Here the primary key is SSN comma P number. That combination is the primary key of this table. So let me take this pen pointer. Okay. So here the combination SSN comma P number is the primary key. Now we will see one example. Here SSN hours is fully functional dependent on SSN and P number because we cannot have a functional dependency SSN to hours. That is, hours is not dependent on SSN alone. Hours, an employee who has worked in a particular project, that does not depend on the SSN value alone. It depends on P number also, on that particular project also. Also, hours is not dependent on P number alone. So it is the hours is dependent on both SSN and P number. This is known as full functional dependency. So we can take another example, SSN comma P number to E name. This is not fully functional dependent because there is a functional dependency from SSN to E name. We can have a functional dependency because E name depends only on social security number. So there is a partial dependency. We call this as partial dependency. So it is important to understand what is full functional dependency. Full functional dependency means the attribute, we cannot remove any attribute from this table or in this functional dependency and still have a functional dependency. That is, if you remove an attribute and say SSN to hours, that does not hold. And also if you remove P number and say P number to hours, that functional dependency also does not hold. So then we can say this is fully functionally dependent. Here, this is not fully functional dependent because we can have a functional dependency SSN to ename because ename depends on SSN alone. So it is partial dependency. So we'll define what is second normal form. A relation schema is in second normal form if every non-prime attribute, let me take this arrow, if every non-prime attribute A in R is fully functionally dependent on the primary key. So if we have to check each and every table, and in every table the non-prime attributes should be fully functionally dependent on the primary key, then we can say the tables are in second normal form. If it does not satisfy this condition, then we have to do the same procedure. We have to decompose it into 2 or 3 relations such that it becomes second normal form. So R will be decomposed into 2NF relations via the process of 2NF normalization, or we call it as second normalization. We will see one example. Here we have SSN, P number, hours, E name, P name, and P location. So if we take the functional dependencies, hours is fully functional dependent on this SSN comma P number, but E name is dependent on SSN alone, and P name is functional dependent on P number alone. P location is functional dependent on P number alone. So there are partial dependencies in this table. So this table is not in second normal form because according to second normal form, there should not be any partial dependency on the primary key. Here the primary key is SSN comma PA number. So there are partial dependencies in this table. So this table is not in second normal form. So what we have to do, we have to normalize it. So we have to decompose it such that the table become tables or the relations become satisfies the second normal form condition. So we have to remove all these functional dependencies and make it into 3 different tables. So the first table will be SSN comma P number hours. Now this table is in first normal form because the non-prime attribute here it is hours. So hours is fully functional dependent on the primary key. Primary key is SSN comma P number. Now the second functional dependency SSN to ename, we have made it into a second table. Here ename is fully functional dependent on SSN alone. So non-prime attribute is functionally functional dependent on primary key. Then here P name, P number, comma P name and P location. Here P name and P location is fully functional dependent on the primary key. So now these 3 relations are in second normal form because it satisfies the condition that all the non-prime attributes are fully functionally dependent on the primary key. The next is third normal form. So in third normal form, we have to define what do you mean by this transitive functional dependency. So a functional dependency x to z that can be derived from 2 functional dependencies x to y and y is to z. Then it is known as transitive dependency. That is, there will be a dependency from x to z. If we have a functional dependency x to y and another functional dependency y to z, then this functional dependency will also hold x to z. Then this is known as transitive dependency. Okay, we will see one example. So in this table, we have a functional dependency SSN to D number, and we have a functional dependency from SSN to D name, and also a functional dependency D number to D manager SSN. So this is X part, and this is Y part, and this is Z part. So there is a functional dependency X to Y and Y to Z. So definitely there will be a functional dependency from X to Z. So this is known as transitive dependency. So as X to Y, Z to Y, and Z to Y, there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Z. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y, Z to Y, and Z to Y. So definitely there will be a functional dependency from X to Y D manager SSN is transitively dependent on SSN. So this is known as transitive dependency because SSN to D number is there, SSN to D number is there, and from D number to D manager SSN is there. So there is a functional dependency from SSN to D manager SSN, or D manager SSN is transitively dependent on SSN. So there is no transitive dependency between SSN to E name because we cannot have a set of attribute X. We cannot have a set of attribute X where SSN to X and X to E name. So SSN to E name is not a transitive dependency. It is a dependency. It is a functional dependency alone. So we should understand what is a transitive dependency in order to define third normal form. Now we will define what is third normal form. So third normal form states that a relation schema R is in third normal form if it is in second normal form. So all the tables should be in second normal form, and also no non-prime attribute in R is transitively dependent on the primary key. So there should not be any transitive dependency to the primary key. So we have to take all non-prime attributes and we have to check whether there is a transitive dependency from the primary key. So if the tables are not in third normal form, we do this normalization procedure. We will do the same thing. We will decompose that relation into two or more relations. So one thing we have to note in this third normal form is that if there is a transitive dependency like this, x to y, let me take this out. Okay. If there's a transitive dependency like this, x to y and y to z, then we say that x to z is a transitive dependency. So this is a problem only if y is not a candidate key. So if y is a candidate key, you know what is a candidate key? The other keys which can be used to uniquely identify. So if y is a candidate key, then it is not at all a problem. We need not normalize that relation at all. So when y is a candidate key, then there is no problem with the transitive dependency. So if y is a y is a candidate key, then it is not at all a problem. So we will see one example. So we have an M table here. Here SSN is the primary key. We have another key here, M number. This is a candidate key and salary. So we have a transitive dependency here. We have a dependency from SSN to M number and M number to salary is there. So there is a transitive dependency from SSN to salary. But this is not a problem here. This is in second normal form because M number is a candidate key. So such kind of dependencies is not a problem if Y part is a candidate key. We will see how to normalize into third normal form. So we have a table M department which consists of these attributes. Here SSN is the primary key of this table. Now we have a transitive dependency here from SSN to D name and D manager SSN. There is a transitive dependency. The non-prime attributes are E name, birth date, address, D number, D name and D manager SSN. So if we check these two attributes, D name and D manager SSN are transitively dependent on the primary key. So there is a transitive dependency of this D name and D manager SSN. So according to third normal form definition, this transitive dependency should not be there. And D number is not a candidate key. So this transitive dependency should not be there. So what we have to do is we have to decompose it into two relations. So we have the first relation like this, SSN, E name, birth date, address and D number. And the second table will be D number, comma D name and D manager SSN. So if we check both these tables, now we have no transitive dependency. So these tables are in second normal form and also these tables are in third normal form. So there is a full functional dependency on the primary key. So it satisfies second normal form and also it satisfies third normal form because there is no transitive dependency. So these two tables are said to be in third normal form. So that is for this lecture. We will summarize. So first normal form relation should not have multivalued attributes. So what we test is we will check whether we have multivalued attributes or nested relations. So if we have multivalued attributes and nested relations, we have to form new relations for which multivalued attribute or nested relations are there. We will remove those multivalued attributes and also remove those nested relations and form new tables. Second normal form, what we do is we should check whether there is full functional dependency. All the non-prime attributes should be fully functional dependent on the primary key. So if it is not there, what we do is we decompose and set up a new relation for each partial key with its dependent attributes and make sure to keep the relation with the original primary key and any attributes that are fully functional dependent on it. That's what we have done in the department table. Then in the third normal form, what we have to check? We have to check whether there is any transitive dependency. Transitive dependency from non-prime attributes to the primary key. If there is any transitive dependency, then we should decompose those relations such that there is no transitive dependency. And also we have to note one thing: x to y2 and y to z. Y is a problem only if y is not a candidate key. So this is the thing what we will learn. We have learned. Next session we will generalize this second normal form and third normal form. So thank you.